going to be a word problem. All right, so two brothers share in cutting their lawn. Tim can cut the lawn in 40 minutes. Jim can cut the lawn in 50 minutes. How long will it take them to cut the lawn if they work together? Okay, so word problems, you want to set up a table, okay? Because the tables help us to solve. So here's our table that we created. So now, with the table, we can work out a solution with this. So, first of all, so we have our two people, Tim and Jim, and they work together. We know the time that Tim can cut it is 40, and we know the time that Jim can do it is 50. Together, we don't know. It's just T. It's unknown. So, fraction of time. This is important because we know in 1 minute, Tim can cut 1/40th of the lawn, and Jim can cut 1/50th. So this helps us with the next part, because this one's the key column, the fraction of work done in T times, because we're trying to find, we're looking for how long. So that's the time we're looking for. So we need T as our variable. So we get T over 40 because time is over that, and T is over 50, and this is 1 because they're cutting one lawn. They're working together to cut the one lawn. All right, so that table now brings us over to this. So now we know they're working together. So from the previous page, from that table, we knew that Tim, that was his fraction of time, and Jim's fraction of time is that. And we know they're cutting together, that's why there's a plus one lawn. Okay, now it's very similar to what you've been doing. We want to find the lowest common denominator, which is 200. We multiply 200 by all the terms, so that's why there's 3 of them there. And then we cross out to get 5, cross out to get a 4. Now we go 5 times t is 5t, 4 times t is 4t, 200 times that is 200. Like terms, divide by 9, and so there is our time. Or if we want to put it in minutes, it's 22.2 minutes. That's the time it will take them to cut the lawn together. All right, so let's try this question. So again, we're doing how long. So it's another time question, so let's set up a little table. We got Mary, and we have Sue, and we have them working together because they're going to be painting a room. All right, so now we know the time that Mary can paint is 4 hours, and we know the time that Sue can paint is that, and they're going to be working together. Now the fraction of time, so in 1 minute, or probably in 1 hour, not 1 minute, we're doing hours, units. So in 1 hour, she can do 1/4, 1/4 of the room, and Sue can do 1/3. All right? Now they're going to be working in time, so this becomes t over 4 and t over 3, and they're cutting the one room. So that's how you set it up. So now they're working together, so it's t over 4 plus t over 3 equals the 1. Find our lowest common denominator, so we know it's 12. Don't forget that term over there. Cross out, so 3t plus 4t, and 12 times 1 is 12, like terms. Divide by 7, so the time they take working together, 12 divided by 7 is 1.7 hours. Okay, so that's the time. Okay, the next word problem is we have a bike race that's going from Victoria to Chemainus, and the distance is 140 kilometers. On the way there, the speed is constant, and on the way back, it decreases. I guess because of the hills, or maybe the wind, or the weather kicked up. But the total race takes 8.5 hours. So again, this is a word problem, so the table is very, very important. Now, you've probably done physics. This formula right here you're going to be using, because we have distance, we have the rate, and we have the time. So this is where we set up the table. Distance times rate equals time, right? So you have all those things. All right, so now, so what we're going to do now is find all right, so now let's fill in the details. So the trip to Chemainus is 70 and the trip back is 70 because it's 140 in total. And we know the trip to Chemainus is a constant x, and the trip back is x minus 6. It's slower, it's decreasing. So that's why we have a minus sign there. All right, and we know this formula comes into play. Distance, which we know is 70, is on top of x. And same thing here. The distance of 70 is on top of that. And what's the total time? Well, the total time is 8.5 hours, right? 5, or 17 over 2 is a good one. Now we put it into an equation. So the equation, we have that plus that equals the total time. So now we are going to calculate the answer. So what do we have? Let's flip over the page. So there's our equation. So we're going to find the lowest common denominator. So we have all three different parts. They're all different. So that is our common denominator, all three parts. So we have it there, we have it there, we have it there. So now we cross out, we cross out, we cross out. Okay? Now the leftovers, we have a 2 and a 70. So that all multiplies to that. Here we have a 2 and an x and a 70. And that multiplies to that. Left over here is we have that, that, and they all multiply to that. All right, so now let's move things over, because this determines movement. This term right here, because it's the x squared. So these guys are going to move over to the other side to make it into a quad equation. So bring them over. Now we're going to go to our calculator, punch in using our quad program. All right, and out comes 20 or 2.4. All right, so what we're trying to calculate is their speed. Well, no one can ride 2.4 kilometers per hour. It's, because if you put it in there, you're going to get a negative answer. And you can't be going negative. All right, because remember, this is your x. So the x is going into, back to your table. If you look back at your table, right? It's going into here. And if we had that 2 point whatever it was, we're going to get a negative answer. So that's why that one we just sort of discard, we throw out, because you can't have a negative speed. So our answer is 20 kilometers per hour. All right. So now the last one, and we're done learning guide 13. And this one's an important one. Okay, so Simon Whitfield won the gold medal in the 2000 Summer Olympics in the triathlon. He swam 1.5 kilometers, biked 40 kilometers, ran 10 kilometers. So his rate of speed for the run was x, for the bike it was 2x, and it's x over 4. So what I'm going to do is set up a table here. So when you have these word problems, we're going to set up a table. All right? So we have the swim, the bike, and the run. Those are the three parts we have. So we have distance, rate, and time. So, okay, what is, oops, it goes down here, distance, rate, and time. So what are we going to put in? Keep hitting the wrong buttons here, sorry. So we are going to put in the distance that he swam. So we know that's 1.5. And we know the bike is 40, and the swim is 10. All right, so he ran. Well, his speed is x over 4, and his bike is 2x, and his run is x. All right, so now, remember this is going time equals the distance over the rate. So we know we have 1.5 is over x over 4, and we have 40 is over 2x, and we have 10 over x. Okay? So here we have complex fractions. We did this earlier. So there's our complex fractions. We times that by 4, times that by 4. So we get 6 over x. Okay, now we're going to put all this together because it's asking the first part, determine an expression. Okay, so we know we got 6 over x plus 40 over 2x plus 10 over x. We can simplify that. To 10 over x, okay? So now that's the answer to A. Now to get the answer to B, we are just going to substitute, because they gave us a time. The rate is 5. So we go back up to our table, right here, and we know the rate of the swim. Okay, so the rate of the swim is x over 4. We know that equals the 5. So we just do a cross multiplying, so x equals 20. And so we get 6 over 20 plus 20 over 20 plus 10 over 20. And we get an answer of 1.8 hours. So that's how long it took him to swim. Okay, that's the end.